Hello and welcome to Systems Lab. In this experiment, we are going to use three multimeters, and we'll show you how the multimeters work just by a simple experiment with a potentiometer, which is of 100K value. So this is Fluke 116. This is in voltage mode. This will be measuring the voltage. This is Fluke 287. This is going to measure the resistance, and this is Vartec. This is in ammeter mode, and it is going to measure the current. So let me just briefly explain you what kind of circuit we are going to explore. So here we have a resistance, and we are going to measure the resistance using Fluke. Okay, so this is Fluke 287. We want to measure the resistance. What we have done, we have put another ammeter in series, which is Vartec. Okay, so this circuit is something like this. Simultaneously, we are also measuring the potential drop across the resistance using Fluke 116. Okay, so this is the pot, and what we understand that in order to measure resistance, when the multimeter is in resistance measurement mode, it sends some current and it measures the voltage drop across the resistance, and by measuring this voltage drop internally, it can apply the equation. It can find out what is V across the resistance, and this is the known current. For Fluke measures this VR, and it knows what current it is sending, and from this it finds out what is the resistance. Now, in order to measure the current, multimeter puts some small resistance in series, and multimeter measures the voltage drop across the internal resistance and finds out what is the current, because this R internal is known. Okay. Now what we are going to demonstrate, that with smaller value of resistance, Fluke multimeter sends higher value of current, so that this drop across the pot is in the noticeable range of the Fluke. Okay, so we are going to demonstrate you this thing first, and here what we will demonstrate, that in ammeter mode, for smaller magnitude of current, the internal resistance of the ammeter is quite high, so that it has noticeable voltage drop across it, and for higher values of current, this resistance is quite low. Okay, so let me now begin the experiment. So you can see there, this is the potentiometer, and all these three are connected in this fashion. Okay, let me just keep it here. Okay, so now you can see that the pot is set to the value of nearly 11 ohms, and here the ammeter is measuring current in 10 ampere range. The reason for putting this in 10 ampere range is that the series resistance is quite small, so whatever resistance we are measuring here is the resistance only because of pot. Okay, and you can see there the voltage drop across pot is 10 millivolt. What it means that Fluke 287 sends 1 milliampere current in order to measure this resistance. Okay, now let me increase the resistance slowly, and we'll see how this voltage changes. Okay, you can see that now it is 154 and this is also 154, so nearly still it is sending 1 milliampere of current in order to measure this pot. Okay, gradually I am increasing and still it is same, it is sending 1 milliampere. Okay, by the way, this is in auto mode. Okay, still we can see that the current which this guy is sending is 1 milliampere. You can see here that now for 1 kilo ohm it's giving nearly 100 millivolts, which means that the current is now dropped to 0.1 milli, 100 micro. I still go on, still the current is 100 micro. You can see now the current is dropped to 10 micro. So higher the resistance value, Fluke is sending smaller current in order to measure, so that the voltage drop across the resistance is in a particular range. I'm increasing it further. Okay. Here it is. Now the current is 1 micro. Okay. And we are almost near the maximum value of this pot. Okay, so here what we have seen that starting from 10 ohms to 100 kilo ohms, we have demonstrated that Fluke sends current in steps of 1 milliampere, 100 micro, 10 micro and 1 microampere. Okay. Okay, so what I told you that now Fluke is sending current of 1 microampere. Now let me just try to measure if it indeed is sending current 1 microampere, and you can see here. Okay, so this is 1 microampere. Okay, now let me. Okay, I'm going down slowly, and I'll see if I want to demonstrate it to you when it goes to 10 microampere. Okay, you can note here that is still, this equation, this is the voltage across resistance, and this is the resistance value, and it is roughly in the range of. And you can also notice there is a difference, even though it displays 1 microampere, there is a difference. The reason being the internal resistance of this multimeter, which is an ammeter mode, is coming in series. You can see here, this is Vartic, and this is coming in series, so which is typically, you can notice here, which is 10 kilo ohms. So 10 kilo ohm is coming due to this. Okay, just notice. Yeah, so you can see there is a sudden jump of 10, And here, if you just follow this equation, you will find that the drop across this potentiometer, it satisfies the equation. Okay. And indeed, this is 10 kilo ohm resistance, which is coming in series. Now let me do it further. Okay, I'll go down and we'll see. Yes, you can also notice that here is a difference. If as per this, you should get nearly 3 kilo ohms, but we are measuring this as 13 kilo ohms, and the reason being that the big resistance here, 10 kilo ohm, is coming in series. Okay, as we know that in higher mode the resistance is different. Okay, so here I can tell you in higher, say, yeah, in now the resistance is very small, the internal resistance is small, and you can see here. Now let me find out how much is the resistance, how much is the current sent by this. So it is 338 milli divided by 3.4. Okay, so it is 100 micro. Okay, so which means if I go to this range, you will get 100 micro. But you can see that in this range there is a difference of nearly 1 kilo ohms, which means that in 200 micro range the internal resistance of Vartec here is 1 kilo ohms, whereas it is 10 kilo ohms in 20 micro range. Okay, so now let me come back, and now in order to have better measurement, yes, so here it is nearly now 1 milli. Now can I measure 1 milli? Yes, it is 1 milli. It is 1 milli, but in this range the internal resistance itself is 100 ohms. Okay, so here we can see Fluke is measuring these two in series. From this we can figure out this one is nearly 162 and 100 ohms is coming from here, so that is the reason why this Fluke is measuring 263. Okay. I go down further. Okay, so let me go to the extreme range once again. Okay, so here we can see that Fluke is using 1 microampere current in order to measure this resistance, and the moment, see what I believe that in this range the internal resistance is 100 ohms. Here it is 1 kilo ohms, whereas here it is 10. You can see that, and yes, we are getting 1 microampere of current. So with this small experiment we have demonstrated that how Fluke multimeter, while measuring resistance, sends or uses current from 1 milliampere to 1 microampere depending upon the magnitude of the resistance measured, and how Vartec, while measuring the current, uses internal resistance in order to sense very small current. It uses internal resistance of 10 kilo ohms, whereas it goes down to 100 ohms or even 1 ohm or even 100 milliohm in this range to measure very high magnitude of current. Hope you like this experiment.